Okay, before we begin the lesson on the green packet, we have to understand that we have the transformations for exponential functions in the following format. If we have a negative a value, then we have a reflection, okay? So again, if you see a negative symbol, it's going to be a reflection across the x-axis. And for your a value, if it's greater than 1, it's going to be a vertical stretch. You can also refer to this as a vertical expansion. If your a value is between 0 and 1, then you have a vertical compression or shrinkage. And for the following term, for the b, this is your base. Then if your h value is a plus h, it's going to go to the left. If you have a negative h, it's going to go to the right. For the k value, if you have a positive k, it's going to go up. If you have a negative k, it's going to go down. And this k value is also known as the horizontal asymptote. Which is represented algebraically by y equals k. Now, the horizontal asymptote is a line that our graph or function gets very close to. It approaches it, but never intersects, okay? All right, let's go ahead and begin our lesson. Here we go. Now, keep in mind that you are doing the graphing with Desmos or your calculator. And for this one, we can easily see that the k value, let's go back here. If the a value is not given to you, it is always known to be a 1, okay? But if the k value is not given to you, it is always known to be a 0, okay? Just keep that in mind. All right, let's go ahead and begin right here. So looking at this function, f of x equals 2 to the power x, notice that we are given the k value as k is equal to 0. Which implies that the horizontal asymptote, which is HA for the shorthand notation, is given to us by y is equal to 0. From there, we can also notice that the a value is given to us by a is equal to 1. Now from there, I can easily see that the y-intercept is going to be located at 0, 1. But you never know, sometimes you might get a transformation that will change this, so definitely keep that in mind. From there, if you were to graph this on Desmos, you would see that you would get the following points of accuracy. At 0, 1, 1, 2, 2, 4, and 3, positive 8. From there, we will then graph this on the coordinate grid. I always begin by graphing the horizontal asymptote. In this case scenario, it is at y equals 0. So I have a dashed line across y equals 0, like this. And I'm going to label it y equals 0. That's my HA. And I will go ahead and plot the following points. I have 0, 1 located right here. That's my y-intercept. And I have 1, 2 right there. I have 2, 4 right here. I have 3, 8 right here. And from there, I will then connect these points and I have the following graph. Keep in mind that you're not intersecting the red graph. You're not crossing it. You're not intersecting it. It's a horizontal asymptote. Okay, so we're going to get a graph that looks something like this. From there, we will then describe the graphical attributes, which are the domain, range, and so on. In this case scenario, we need to know that the domain of all exponential functions will be from negative infinity to positive infinity, or essentially all real numbers. We can also indicate that this is represented by the fancy letter R. Okay, so if you ever see either of these notations, that represents all real numbers. Now, for the range, keep in mind that range is read from bottom to top. So looking at the coordinate grid that I have on the right-hand side, do I have a graph in the bottom? No, I do not, but I do have a starting point at y equals 0. So I will write down that my range begins at 0, but I do not include it, so I have a parentheses. Now, why do I put a parentheses? Again, because I have a horizontal asymptote at y equals 0. I cannot be exactly on 0. Comma, and then for the top portion of the graph, I notice that I do have a graph that continues upwards, which means that I have positive infinity. So my range is going to be from 0 to positive infinity. My y-intercept is going to be located at 0, 1. Now, in order to determine whether the function is increasing or decreasing, we have to answer this question right here. I'm just going to put this in quotes. What's happening to y as x goes right? That's the question that we are answering. So looking at this graph right here, notice as we go further and further to the right-hand side of the graph that we have in yellow, notice that the y values are going upwards. They're increasing. So hence we can indicate that this graph is going to be an increasing graph, an increasing function. Okay, let's go ahead and move on to the next question. Now for this one, notice that we do have a transformation. So this one's a little bit different, okay? So looking at this, notice that our k value, which is the horizontal asymptote, is going to be 0. We do not have a k value here. That +2 right there on top, that's for the h value, correct? That's for the movement going left and right. So in this case scenario, I have a horizontal asymptote located at y equals 0. From there, on the right-hand side, I will then sketch my horizontal dashed line for the HA. So this is y equals 0. That's my HA. And now for the points of accuracy, I have them located at -2, 1, at -1, 2, at 0, 4, and at 1, 8. From there, I will then plot these points on the coordinate grid. So I have a point of accuracy at -2, 1, which is located right there. I have another point of accuracy located at -1, 2, which is right here. Another point at 0, 4, right there. That's my y-intercept. And at 1, +8. Okay, from there, I will then connect these points, and I should have a graph that looks something like this. Okay, so now looking at this graph, we will then answer the graphical attributes on the left-hand side. So looking at this, we will indicate that the domain is going to be, remember, domain is left to right, and it's going to be from -infinity to positive infinity, or essentially all real numbers, or you can use the fancy capital R for the notation. Okay, so from there, now keep in mind that the domain will always be the same from -infinity to positive infinity for all function types, or excuse me, for all exponential functions. Now, the range is what's a little bit different. For this one, keep in mind, range is bottom to top. So do I have a graph in the bottom? No, I do not, but I do have a starting point at y equals 0. So I begin at 0 right there, and I do not include it. It's part of the horizontal asymptote. And our graph is going to continue to go upwards, so hence I have a positive infinity. From there, I then have my y-intercept located at 0, 4. Now, to determine whether the function is increasing or decreasing, we ask ourselves what's happening to the y values on our graph as I go towards the right-hand side. What's happening to the y values? Well, looking at this graph, notice that they're going upwards. They're increasing, so hence I have an increasing function. Let's go ahead and circle that right there. And for the transformations, we can say that g of x is translated left 2 units. Okay, let's move on to the next question. So for this one, notice that we're given g of x is equal to -2 to the power x plus 1 minus 3. Now, keep in mind that if you ever have an exponent, for example, the previous question, we had an exponent that had more than one term. Keep in mind that for Desmos, or perhaps on your calculator, not all calculators have this issue, but on Desmos, you want to wrap this exponent with parentheses to ensure that you can type this into Desmos. If you do not do that, you will not be able to see this on your Desmos calculator. All right, so again, same idea. You want to wrap this in parentheses when you're typing this into the calculator. All right, so now we're going to see right here that I have a k value of -3, which implies that the horizontal asymptote will be located at y equals -3. From there, I will then graph my horizontal asymptote at y equals -3, which should be located right here. So this is y equals -3. That's my HA. Then I will find points of accuracy for this function. So I'm going to go ahead and create that table right here. Okay, so this is my x, this is my y. I have -1, -4. I have 0, -5. And I have 1, -7. From there, I will then plot these points on my coordinate grid. So I have -1, -4 located right there. I have 0, -5 located right there. And 1, -7. Now, looking at this grid right here, we cannot fit 1, -7, but I'm just going to say it's going to be somewhere right here. And based on the graph that we have on our calculators, we should have a graph that looks something like this, okay? Again, do not intersect that red graph, that horizontal asymptote, okay? So we should have a graph that looks something like this, okay? Now, based on the graph that we have, now we can answer the graphical attributes. So looking at the left-hand side, the domain is going to be from -infinity to +infinity. That's going to be the same for all exponential functions, regardless of any transformation occurring. From there, the range is going to be from what? Well, range is bottom to top. Do I have a do I have a graph in the bottom? Yes, I do. So hence, that's going to be represented by -infinity, comma. And then do I have a graph on top? No, I do not. But I do have a stopping point at y equals -3. So my range is going to be from -infinity to -3, not including that -3. So place a parentheses. The y-intercept for this one is going to be located at 0, -5. And looking at this function, how do I determine whether it's increasing or decreasing? Well, I look at the left-hand side going towards the right-hand side. What's happening to the y values? Well, they are decreasing. As I go further and further to the right-hand side, the y values are decreasing. So let's go ahead and circle that, decreasing. The transformation for this one is going to be the following. G of x is reflected across the x-axis and translated left 1 unit, and down 3 units. Okay, let's move on to the next question in 3, and 2, and 1. Okay, now for example number 4, we are told that we're given f of x is equal to 1.5 times 3 to the power x. And we have g of x is equal to 1.5 times 3 to the power x minus 2. Now, they're telling us that g of x is a transformation of f of x, okay? So what we have to do is graph g of x on the coordinate grid. This graph that's in blue is the graph of f of x, okay? So the first step that I'm going to do is identify the k value. So looking at the g of x function, my k value is -2, which implies that the horizontal asymptote, which is the HA, is going to be y equals -2. So on the coordinate grid, I will graph y equals -2, like this. This is my HA. And I'm going to plot the points of accuracy. Now, for this example, for this function, I have the following points of accuracy. So I have my x, I have my y, and I'm going to plot the following points. Now, for this one, sometimes we have a function in which the values are not going to be whole numbers, and that's okay. So for this function, we don't have that many whole numbers that would fit in the coordinate grid, okay? So I will say that I'm going to use the following points: -1, comma, -1.5. I have 0, comma, -0.5, and I have 1, comma, 2.5. From there, I will then plot these points. I have -1, comma, -1.5 located approximately right here. I have 0, comma, -0.5, which is the y-intercept located right there. I have 1, comma, 2.5 located right here. And based on my graph from my calculator, I should have a graph that looks something like this. Okay. Now, looking at this graph, we will then answer the graphical attributes. On the left-hand side, the domain is going to be from -infinity to +infinity, or essentially all real numbers. The range is read from bottom to top. So what's the starting value in the bottom? Well, it's going to be -2. And for the top part, it's going to go to +infinity. My y-intercept for this one is located at 0, comma, -0.5. And looking at this graph, it's going to be an increasing function. Why is it increasing? Well, as I go further and further to the right-hand side of this graph, the y values are increasing. They're going upwards, okay? So that's an increasing function. And for the transformation of this function, we're going to indicate that g of x is, and again, we're comparing it to f of x, so we have to be careful about this, okay? So the only difference that I see between f of x and g of x is that g of x was translated down 2 units, okay? So let's write that down. G of x is translated down 2 units, okay? Moving on to the next question, we have f of x is equal to 1/4 to the power x. For this one, notice that the k value is going to be 0, which implies that the horizontal asymptote will be located at y equals 0. From there, I will then identify the points of accuracy. So looking at the table that I have from my calculator, I have -1, comma, 4. I have 0, comma, 1. And again, it's okay to have some decimals in there if you cannot find any other points that fit in the graph. So the next point that I have is 1, 0.25. And I think that's the furthest that I can do. All right, and now I am going to plot my horizontal asymptote at y equals 0. That's my HA. And I'm going to plot the following points. I have -1, 4, so this is -1, 4 right there. I have 0, 1, which is my y-intercept, and I have 1, 0.25, which is going to be somewhere right there. And now, connecting these points, I have the following graph. Keep in mind that this is just a rough sketch. It doesn't have to look perfect, but the graph is going to look something like this. Okay. All right, now we can answer the graphical attributes question. So looking at the left-hand side, the domain will be from -infinity to +infinity, all real numbers. The range is going to be from bottom to top. So looking at this, guys, notice that we have a starting point at 0. So we begin at 0, not including it. And our graph continues to go upwards, even though it's in a different direction, it's still going upwards. So I have +infinity. Okay, now for the y-intercept, we have it located at 0, 1, and whether it's increasing or decreasing is based on the following. So as I go further and further to the right-hand side, what do I notice for the y values of my graph? What do I notice? Well, I notice that the y values are decreasing. They're getting smaller and smaller as I go towards the right-hand side. Hence, I have a decreasing function. Let's go ahead and circle that. Decreasing. All right, let's move on to the next question. For this one, we have g of x is equal to 1/2 to the power x plus 4 plus 2. My first step is to identify the k value. So looking at this, my k value is going to be +2. From there, that indicates that the horizontal asymptote is going to be y equals 2. I will then identify the points of accuracy using my calculator or Desmos. So looking at this, I have -7, 10. I have -6, 6. I have -5, 4. And I have -4, 3 for the points of accuracy. Now from there, I will then begin by plotting the horizontal asymptote at y equals 2. So this is y equals 2. That's my HA. Then I will plot the points of accuracy. I have one at -7, 10, which is located right here. I have another point of accuracy at -6, 6, which is right there. I have another point of accuracy at -5, 4. So this is -5, 4. Then I have another point of accuracy at -4, 3, which is right here. And based on the graph that I see on my calculator, I should have something that looks like this. Again, do not intercept that red graph right there. Try to get as close as you can as possible, but again, do not intersect it. All right, so that's how my graph looks like. Okay, and now we're going to answer the graphical attributes question. So on the left-hand side, for my domain, it's going to be from -infinity to +infinity. For my range, it's going to be from what? Bottom to top. So I begin at y equals 2. I do not include it, so I have parentheses 2, comma, and then I have what else? Well, I see that my graph continues to go upwards. Even though it's in a different direction, it's still going upwards. So I have +infinity. For the y-intercept, it's located, and now this one's a little bit difficult to see on your calculator, but the y-intercept is going to be located at 0, 2.0625. Then, whether the function is increasing or decreasing, based on the example that we saw above, this is going to be a decreasing function. Then we're going to answer the transformation. Okay, so for the transformation of this function, we notice that g of x is translated left 4 units, and up 2 units. For the next question, we have g of x is equal to -2 times 1/2 to the power x. So my first step is to identify the k value. The k value right here is going to be 0, since it's not given to us. Hence, the horizontal asymptote is going to be at y equals 0. From there, we will then identify points of accuracy. So on the left-hand side or right-hand side, I will create a table of values. And I see that I have -2, comma, -8. I have -1, comma, -4. I have 0, comma, -2. I have 1, comma, -1 for the points of accuracy. So on the right-hand side, I am going to graph my horizontal asymptote first at y equals 0. This is y equals 0. And I'm going to plot my points of accuracy. -2, comma, -8 should be located right here. I have -1, comma, -4, which is right here. I have 0, comma, -2 right there. I have 1, comma, -1 right there. And based on the graph that I see on my calculator, I should have a rough sketch that looks something like this. Okay, and now we can answer the following graphical attribute questions. So for the domain, it's going to be from -infinity to +infinity. For the range, it's going to be from bottom to top. So looking at this, guys, do I have a graph in the bottom? Yes, I do. And it continues to go to the bottom, which indicates that I begin at -infinity. And I look at the top. Do I have a graph on top? No, I do not. I have a stopping point at y equals 0. So hence, I have from -infinity to 0 for the range, not including 0. The y-intercept for this one is going to be located at 0, comma, -2. And for the transformation, I am going to indicate that g of x is reflected over or across the x-axis and vertically stretched or expanded, your choice. We're going to say stretched by 2. Okay, moving on to the next question type. We have to graph, or excuse me. Oh, it's not, let me see. Okay, well, for this one, we have to graph the exponential function with a restricted domain of -1, comma, 4, and this is going to be for the following function. It's going to be for y is equal to 2 to the power x, okay? Now, for this one, when you graph it on Desmos, and since I do not have the coordinate grid, I'm not going to be able to do it here, but we're going to get something that looks like this for the table of values. Keep in mind that the restricted domain are the x values. So I have to go from x equals -1, x equals 0, 1, 2, and 3, and 4, okay? So this is my x, this is my y, and this is going to leave me with -1, comma, 0.5, 0, comma, 1, 1, comma, 2, 2, comma, 4, 3, comma, 8, and 4, comma, 16 when I click on the table of values. But keep in mind, even though you can go to the x equals 5, x equals 6, and so on, you want to stop right here. This domain is restricted between x equals -1 and x is equal to 4. Now, the question that you will most likely see on the test is going to ask you, what is the range, okay, given this restricted domain? And your answer should be the following. You should say that the range is going to be from 0.5, and this is going to be included with a bracket, comma, all the way to +16. Or you can give this in a different format. So this is the interval notation. We can also give this as an inequality notation by saying y is less than or equal to 16, or y is greater than or equal to the 0.5. That's the other notation that you might potentially see. Okay, now let's go ahead and move on to the next question right here. So this is based on the transformations. Now, for this one, it indicates given the function and the transformations below, write the equation of the transformed function g of x. Now, this one is based on f of x is equal to 3 to the power x. So that's the original function. So looking at this, I will easily say that this is going to begin with the reflection across the x-axis, which is going to be the negative symbol. I keep my 3 to the power x. Then it indicates what? Translated to the right by 1 unit. So I have minus 1 on the exponent. And then finally, I have the translation 7 units down. So it's going to be minus 7 down below. For the next question, we're told the same, given the function and the transformations below, write the equation of the transformed function g of x. This is going to be for f of x is equal to 1/2 to the power x. So for this one, I have a negative symbol in the front for the reflection across the x-axis. I keep the same function, 1/2 to the power x. But then it says what? Translated 1 unit to the right, so this is going to be minus 1, and then 7 units down, so this is going to be minus 7 down below. Now it's asking us what's the domain of g of x. I will easily say that for all for all exponential functions, the domain is going to be from negative infinity to positive infinity. Okay, next we will then answer the following question, okay? Now, for the range of g of x, here's what I would say. Now, this graph is going to be reflected across the x-axis, right? And we have a horizontal asymptote at -7, okay? Since it's going to be reflected, I will say that the graph is going to be from negative infinity to -7, not including -7. Okay, let's move on to the next question type. So for this one, it says, given the functions below, state the transformations that occurred, it should say that occurred, from f to g. So looking at this, I easily can say what? That g of x was translated left 2 units and down 3 units. Very simple. Okay, for the next question, we have determined whether each statement is true or false about the function y equals 4 times 2/3 to the power x minus 3. If false, correct the statement. Okay, here's the first statement. The horizontal asymptote is y equals 4. That's not the case for this function. If you were to graph it, you would easily see that the k value right here represents the horizontal asymptote. So this is going to be false, comma, it's y equals -3 for the horizontal asymptote. And if you were to graph it, you would also see that the graph is not increasing, it's actually decreasing. So go ahead and write down false, it's decreasing. Okay? Then it's asking us or telling us that the statement is the y-intercept of the graph is is 0, 2/3. That's not the case. This is going to be false. It's at 0, 1 if you were to graph it. For the next question, we're told to find the horizontal asymptote of each of the following functions. So for the first one, we're going to indicate that the horizontal asymptote, HA, is y equals 0. There's no k value, so that's why it's y equals 0. For the next question, we have HA is y equals -4. Keep in mind that HA is the horizontal asymptote in the shorthand notation. And for the next question, we have HA is y equals 1. For the next question, we have HA is y equals negative 2.5. For the next question, this one doesn't have a k value. Looks a little bit weird, but the HA for this one is y equals 0.